Hello, this is Dr. Umesh, PhD in chemistry, and for last 22 years, I have been teaching chemistry for grade 11 and 12 in India for different national and state boards, and also teaching online for IB, IGCSE, EdExcel, and all the international boards. In India, students contact me for preparing the NEET and JEE entrance examination. Many students have cracked their competition examination through my classes. Now, I'll show you a demonstration how I teach online. I'll be discussing few questions based upon the organic chemistry. So I'm sharing my screen with you and we'll discuss some questions, only 2 or 3 questions to demonstrate how I teach. I'm sharing my screen with you. So this is one question I can show you here. The electrophile among these is. To understand what is electrophile, first of all, we need to understand the definition of the electrophile. You know, electrophile is the substance, it's an attacking species that is electron deficient and attacks upon the carbon positive. That is called electrophile. So, coming to the question here, which is the electrophile here? If you see the structure of all these compounds, if I see the ammonia molecule here, first I'm taking the third option here. You can see the structure is like this, and it is capable of donating electron pair. It is not a electrophile, but it is a nucleophile. And RO negative, R stands for any alkyl group, let it be methyl group and oxygen with a negative charge. It is also capable of electron donating. It is capable of electron donation. So this is also nucleophile. And if you see this alcohol journal formula, this has a lone pair of electrons and it can donate electron pair. So this is also a nucleophile. But if I see the structure of the boron trifluoride, this molecule here, and draw its structure, so the chemical bond, you know how to draw the structure, you can see that this compound is a hypovalent compound. The central element has 6 electrons in the outermost shell. This is hypovalent compound. It means this is a electron deficient compound and that will be attracted towards the electron cloud, electrophile. So this is the correct answer, that is the BF3. So we can click that, this is the correct answer. So let us discuss one more question here. The number of electrons in the central atom or the free radical. 4 options I'm giving you here. 6, 7, 8, 10. How many electrons are there on the central atom? So let us draw the structure of this methyl free radical. Carbon. We know that carbon has a valency 4. And here the 3 hydrogens are bonded here. And hydrogen has a valency of 1. So I'm drawing here the Lewis dot structure of this free radical. This is sharing takes place here and covalent bond is formed. And this is the one free electron here. Now count the number of electrons around the central atom here. 1, 2, 3, 4, 5, 6, and 7. It means my answer is here is 7. So that's how we solve these questions of the organic chemistry. It's a very basic question, very simple question. Let us discuss one more question here. The carbocation among this is. First of all, before I answer any option, we should understand what is a carbocation. The carbocation is a reaction intermediate in which carbon atom is having a positive charge. You can see the carbon with a carbon, cation is positive charge species. So any species that is having carbon with a positive charge, it is a intermediate, it's a reaction intermediate that is called the carbocation. It is having 6 electron outermost shell. So which among this is the carbocation that we have to decide. If you see the first option here, this is the carbon, and I'm expanding the structure of this first option, so I can draw like this. And this is the 1 electron here. This is not a carbocation, rather it's a free radical because it is a 1 free electron. And talking about the second option here, this one. So carbon, negative charge is mentioning here. It means here the carbon is having 1 extra electron negatively charged. I had drawn its expanded structure. This is not a carbocation. It is not carrying any positive charge. Rather, it is a carbanion. It is a reaction intermediate which contains negative charge. It's a carbanion. And not talking about a third option, carbon with a positive charge. Yes, it is satisfying the condition, definition of a carbocation. That is a carbon with a positive charge. So it is having a positive charge over here. So this is the correct answer. So let us see the last option also. The carbon is bonded with 4-methyl group. It is not having any charge. It is not having any charge. It is just a neutral molecule. So this is not a carbocation. So carbocation is the reaction intermediate in which carbon atom has a positive charge on it, and it's a reaction intermediate that will be attracted towards something negative. So this is the correct answer. Let us discuss one more question here. The most reactive free radical among this is free radical. Third butyl, the structure is like this. First of all, you should understand that we have to draw the structure, then only we can finalize the answer with some basic concept. Now, thick butyl means it is the free radical is on the second carbon atom. So it is a thick butyl. And isobutyl is this structure. It's a common name. And N-butyl means just a straight chain, and the terminal hydrocarbon atom has a 1 free radical. So we know from the basic concepts that this, the last one, see, this is a primary free radical. The carbon on which free electron is here, that is directly bonded to one more carbon atom. So this is a primary free radical. This is a secondary free radical. This is again a primary free radical. And the carbon atom on which the free electron is there is bonded with the 3 other carbon atoms. This is called as a secondary free radical. Now, we know that the stability order of these free radicals. 3-degree free radical is more stable than the secondary, and the secondary is more stable than the primary. This is about the stability of the free radical, order of stability. And we know from the basic concept of organic chemistry that if in any chemical reaction, the intermediate is more stable, the rate of reaction will be very, very fast. It means the most reactive intermediate is the one which is most stable among this. So this is the first option, that is the correct answer. So that's how we can discuss questions, multiple choice question or subjective questions of your examination level. Right? It's very basic, as I have discussed with you. Hello, this is Dr. Umesh. This is a demonstration lecture on. So now let us continue and discuss this question here. The species having maximum number of electron pairs on the central atom, maximum number. First of all, please highlight here, focus here, what is being asked in the question. Maximum number of electron pairs on the central atom. So let us first of all draw the structure of these species and then see how many electron pairs are present, and then we will decide the maximum number of electron pairs. So in my previous questions and our basic theory, we know that what is free radical. This is a free radical, right? This is the structure of the free radical where R stands for hydrogen, or it can be an alkyl group. Now, as far as the number of the free electron pairs are concerned, you can see this is a 1 pair, 2 pair, 3 pair. So I'm fixing here that here we have a 3 pair of electrons are there. Similarly, now we draw for the carbanion. We know this thing. Carbanion is having a negatively charged carbon atom with 8 electrons in the outermost shell. And on the central atom, if you count the number of the electron pairs, 1, 2, 3, and 4. So we have a 4 pair of electrons. So let us count in the other 2 options also. Carb-cation. And in my previous questions, I have discussed what is the carb-cation. Carbon with a positive charge on the central atom. And say alkyl group or the hydrogen here. And now let us calculate or let us count the number of the pair of electrons here. 1, 2, and 3. Again, I can say I have 3 pair of electrons here. And the carbene is this intermediate here. It is a neutral molecule, neutral intermediate. So it has only, again you can see 3 pair of electrons. So which has maximum number of electron pairs, that what I can find in the carbanion. So we have decided the answer, carbanion. I hope it's very clear to everyone. Now, let's discuss another question here. The geometry of the alkyl carbanion. Geometry, carbanion, alkyl carbanion. The carbon is having one negative charge, we know that. And this is the alkyl carbanion. You can see it has a 4 pair of electrons. And from the VSEPR theory of the chemical bonding, from the VSEPR theory of chemical bonding, that whenever we have the 4 pair of electrons around the central atom, they will align in the tetrahedral geometry like this. Let's say R group here. This is away from the observer. This is towards the observer. The bold line I'm showing that is towards the observer. And this is the electron pair that makes it negative. We can say that this is a tetrahedral geometry with a bond angle of 109 degrees. So the geometry is here is tetrahedral. So we say it's a tetrahedral geometry. The geometry of the carbanion is tetrahedral. So let us discuss another question here. The correct order of the stability of the carbanion among this is. See, what are the options given to us is the methyl, primary, secondary, and tertiary. Carbanions are given to us. So let us understand here what is the correct geometry here. This is a 0 degree is nothing, right? This is a carbanion. We call it a primary carbanion or 1 degree carbanion. Or if the carbon is bonded to one more carbon atom directly here, like this is also a primary carbanion. And now if we have the carbon with a negative charge and bonded to 2 carbon atom directly, this is a secondary carbanion. And the carbon on which the alkyl group is there, the carbon is bonded directly to 3 other carbon atoms. In that case, we call this is a tertiary carbonide. Before we discuss the stability order, we must understand that this alkyl group is electron donating group. It causes a plus I effect, positive inductive effect. It's an electron donating group. So when it is a electron donating group, it will intensify the negative charge on the carbon atom. If the charge intensification takes place by the plus I effect of the alkyl group, the stability will decrease. It means if I talk about the methyl carbonyl and the primary carbonyl, the primary is more stable. Here we have a two-side plus I effect. The plus I effect is coming from the two sides. Plus I effect is coming from two sides. Electron donation is from the two sides. It means here we have more charge intensification. The negative charge is intensified more as compared to the primary carbocation. And as the charge value increases, the stability will decrease. So secondary is less stable. Right? I'm talking about that last one, more the plus I effect. More the plus I effect, more three-side plus I effect you can see. The inductive effect from the three sides, electron donating groups from the three sides. This is going to intensify the negative charge maximum as compared to the primary or secondary. Here it is maximum plus I effect, maximum charge. It means least stability. So considering all this, we can say the methyl is more stable than the primary, and the primary is more stable than the secondary, and secondary is more stable than the tertiary carbanion. So if you check the options here, I can clearly find the option number 1 is the correct answer. So this is the explanation of this question here, how we decide the correct option, right? Before just answering the question is not sufficient. You should know the background of the topic. If I talk about the stability of the carbanion, so that you should know the factors on which the stability depends. Now, let us discuss here another question here. The reaction intermediate among this is free radical, methyl free radical, methyl carbocation, or methyl carbanion, or all of these are reaction intermediate. Yes, all of these are reaction intermediate. This is not a reactant. All of these are not reactant. These are not also the stable products. These are formed during the reaction. And then finally the product is formed. So answer is all of this is the correct answer. Now, let us discuss here another question here. Which of the following is more stable than the remaining three? It means we have to decide the most stable here. T for tertiary, third butyl carbocation, carbanion. Third butyl means I had told in my previous question that the carbon which contains the charge, negative charge, is bonded with 3 other carbon atoms. We call it a third. Now isobutyl carbanion is this one. The plus effect, right? This is isobutyl. Methyl carbanion is this one. And ethyl carbanion, ethyl means 2 carbon atom here with a negative charge. The 4 structures I have drawn here, all these structures contains or carries a negative charge. The basic idea about the stability is more the charge, less of the stability. Understand? More charge, less stability. And the charge is decided by the adjoining bonded atoms or group of atoms. And here the bonded atoms are basically methyl group or the hydrogen, which are causing the plus side effect over here. Here we have the plus side effect from the 3 sides. maximum intensification of negative charge, and that is why making it less stable. Here we have plus side effect from one side. Here we have plus side from one side. But here, in case of the methyl, the hydrogen inductive effect, we know it is equal to 0. It means it is not electron donating, it is not electron withdrawing. Its electronegativity is similar to that of carbon atom. It means it is not intensifying the negative charge. So the stability will be minimum, stability will be maximum here. Less charge, more stability. So we say option third is the correct answer. Now, let us discuss the last question here of this demonstration class. Type of the hybridization, geometry of the butyl, tertiary butyl carbocation. Again, go to the structure. Without structure, it is not possible to answer. So chemistry is all about structure analysis, structural analysis, right? So here we have a third butyl with 3 carbon and 4 carbon atoms here with 1 positive charge. Third butyl. This is a third butyl carbocation. And this is the central atom which carries a positive charge, is having 3 pair of electrons, right? So this will be now sp2 hybridized. And from the VSEPR theory, that these lone pairs will be repelling each other in such a way that they get the maximum stability and minimum repulsion. It means they will repel in one plane such that out of the 360-degree total angle, they should be equally spaced at equal angle. That is possible at 120 degrees. I can say third, 1 by 3. And this geometry, what we get is called as a trigonal planar. This is the answer, sp2 and trigonal planar. I hope all these questions are very clear to you. Now, let us come to the termination of this demonstration class. This is how I teach. First, we teach the basics. Then we come to the question practice. But here today, I have discussed multiple choice questions. Then we can discuss the question of the subjective and analytical and the experiment-based questions. Everything can be done. So, I invite you all to my classes here. Right? You can join my classes for the complete syllabus or the chapter you want to discuss, or you can also discuss your doubt session with me. So see you very soon in my classes now. Thank you very much.